Projectile motion. What is it, you might ask? Well, you've come to the right place. One might say that it's the projectile motion. I guess, if you wanted to be all technical about it, you could say it's the motion or path of an object through air. Here, let's say you have a dog. Look at this dog. It's lazy. It's a lazy dog. It will not run more than 15 meters max. And honestly, can you blame it? No, it's a lot. But that means if you ever get it up to play fetch, you need to make sure that you don't throw that ball more than 15 meters. Otherwise, you will be the one getting up to get the ball while she waits for you to bring it back. You don't want to be the dog in the fetch scenario. That's too much. It's too much work. To figure out exactly how to throw that ball so it won't go past the 15-meter mark so you're not getting it, you gotta use some projectile motion math. First thing you should know is that the path is controlled by two external forces. The first one, the big one, is, you guessed it, gravity. Yeah, that big force holding you to Earth so you don't float away to space kind of has a thing in making things fall back down. The second one is air resistance, but we're just going to ignore that one right now because it's so small it basically means nothing in this problem. Also, it's a little past the knowledge of a basic biomechanics student such as myself. There's you. There's your dog. You got it up. You're ready to play fetch. You're getting ready to throw the ball. But wait, make sure you're not going to throw it too far. Let's think about this. There are three key factors affecting something's parabolic path. The first, projection velocity. The second, projection height. And the third, projection angle. Okay, so let's take a look at the different variables you are going to have for this problem. Let's look at projection height first. Projection height is the height difference from where the projectile will land versus where the projection took off from. For this example, the tennis ball will take off from 1.5 meters above the ground and land at ground level. The projection angle is the angle at which a projectile is thrown. It's hard for a human being to throw something at an exact angle, but for this, we're going to say you regularly throw at a 40-degree angle. Projection velocity is the velocity at which the projectile, in this case, a tennis ball, is thrown. You have to make sure the ball is thrown far enough that the dog will get exercise, but not far enough that the dog won't run and get it. So that's what we're going to find. How hard, aka at what velocity, should you throw the ball so it will go about 10 meters? There are three equations of constantly accelerated motion. Here they are. Usually, these can be used to determine the necessary variable for a projectile motion equation. Because our problem has a different landing and starting height, the initial velocity does not match the final velocity. So, we are missing the initial velocity, the final velocity, and time. Here I have written out all of our known and needed variables. Xi and yi represent the distance and height of the projectile initially. Xf and yf represent the initial height and distance of the projectile at its final place. Vix and viy represent the initial vertical and horizontal velocity. Those are still in equation form because we do not know the initial velocity. Ax and ay represent the acceleration vertically and horizontally, and both the initial velocity, vi at the top, and the times are shown as red question marks because those are the variables that we are here to find. Because we don't have the initial velocity value, we are unable to solve for the final velocity, so we'll be using the horizontal and vertical motion equations to solve this problem. There they are. The first thing I did was plug in all of our known values into each of the equations and then simplified them down as far as they could go. I then continued to simplify the horizontal motion equation to solve for time. I substituted the horizontal motion equation for time into the vertical motion equation and then continued to simplify it as far down as I could get until I received one specific number. That number, 9.2 meters per second, is the initial velocity value, which is the number that we set out to find at the beginning of this problem. So, if you want to throw a tennis ball 10 meters for a lazy dog that won't run more than 15, you'll be throwing it at a height of 1.5 meters a degree angle of 40 degrees, and an initial velocity value of 9.2 meters per second. Deej, wanna go play fetch? No, you're not moving.